for the first part, we're going to use our formula, 1/2 times the integral of r squared from an angle to an angle to get that polar area, right? So when I'm looking at this picture here, I'm looking from the windshield wiper right there. You're going from 0 to pi over 2, and you're only traveling along this curve, which is that more complicated looking equation right there. So if I integrate 1/2 r squared of that guy from 0 to pi over 2, that should give me all of this shaded region right here. So that's what I did for the first part of that. And then the second part, we have a couple different options there. You can use your 1/2 r squared formula, and you can go from pi over 2 to pi. And then that 1/2 r squared, that's using this r equals 3 equation there. So that's your 1/2 r squared from pi over 2 to pi. Or you can realize, since that one is just a circle, r equals 3, this is just a quarter of a circle, which you can use your easy geometry formula, pi r squared divided by 4. Either way, for that part, either use the integral formula or the geometry formula, you're going to get that same number, and then use the math 9 on this to get this there, right? So at some point, we can group together all of our polar area problems there and just kind of study those like back to back to back to back, and then you'll feel a little bit better about how to get all your polar area using that formula there. Now for part B, it's talking about the derivative of x's. And so remember, on all these polar ones, if it has you do stuff with x's and you don't have x equals something, because you're given like r equals something and theta equals something all the time. If you don't have x equals to take a derivative of x's or y equals to take a derivative of y's, you got to use your Precalc formula. Simply just remember, x is r cosine of theta, y is r sine of theta, and then they give you the r to use on that. All right, so it says for that r curve, find the derivative of x in terms of theta. So I start with x equals r cosine of theta, substitute the r, so I have x in terms of theta. And then what you can do is just use the math 8 function on this one, because you want to take the derivative of that at pi over 6. So if you hit the math 8 button, type that function in, just use x's, use your variable button instead of the thetas. At that pi equals 6, make sure it's in radian mode. You should be able to come up with that, and then let me know if you're having any issues with that. All right, so part A and part B was, the polar area stuff, the Precalc stuff, and then taking the derivative. Part C was a little bit, you had to think for a little bit. It's talking about the distance between the two curves. And then whatever that distance is, you want to find the rate at which that distance is changing. Now, when I saw the rate at which the distance was changing, that told me right there I was taking the derivative of something. But the derivative of what? Where I need to come up with something that represents the distance between the two curves there. So all you're gonna do, if you want the distance between two things, is just subtract them, okay? So I put down here top minus bottom, even though it's really the bigger radius minus the little radius, but just, if I just normally give you, hey, what's the distance between like two curves there, you're just subtracting like the top curve minus the bottom curve, like when we did area and stuff like that. But essentially what's going on is, like, if I wanna find the distance, like if I wanted to figure out the distance between these two R values, right? What I can do is do the big R value. So that would be like the R equals 3. And then I could subtract out the little R value that goes to that shorter curve. And then I would give me the distance between the two. So I want that R value minus that R value. So that's all I'm doing. I'm doing that 3 minus that other R value, just subtracting them to get the distance between. And then that gave me the distance between the two curves. But then since it said find the rate of change of that, that's when we want to take the derivative. So you have two options there. To me, that was a simple derivative. So I just took the derivative real quickly, plugged in the pi over 3, and then just remember your all students take calculus there. Your cosine is negative in that second quadrant there to get the -2. Or if you really had to, you could use the math 8 function on that. It will take the derivative of that at the pi over 3 and give you that -2 number as well, since this is on the calculator part of the test. All right, now last part of this one, and you guys will, I think you'll like this one once you kind of see that. You'll be like, oh yeah, that's not that bad. I can handle doing that. So they give us this R value, then they want to find a d theta dt. Now this is R in terms of theta. So if I ask you to find dr d theta, that's just your normal derivative where you're going to get the -4 cosine of 2 theta, and then you could plug stuff in or whatever. But if they want the dr dt, remember these are like the related rate problems. So you're going to do the derivative like normal, but since you're taking derivative of thetas with respect to time, you need to remember to tag on that extra piece, that d theta dt. And then they give you a hint anyways, because they give you like a d theta dt is equal to something there. So that's kind of where you're a reminder to plug that in, to tag that in at the end and actually use that at the end there. Okay, so again, if it just says dr d theta, you wouldn't need that extra piece. But since it says dr dt, then you need to tag on that extra piece. And then they gave us what that was equal to. And then he said, find the dr dt when the theta equals pi over 6. So I plugged in pi over 6 times by 2 to give me the pi over 3. And I just, just got that answer right there. Sunny sunshine.